In question 10, we want to get the equation in the graphing form of the square root function. So a square root b minus x minus h plus k. So the h and k are important because they identify the vertex locations. So for all these graphs, it's going to identify the vertex location. So that's where we're going to start with the first one. So we take a look at the vertex here. So we end up with y equals a square root b, and the vertex is at -3, +4. So it's going to be x plus 3 plus 4. Okay, so based on that, then we can look at the expansion compression points. So if I take a look at these points here, that's 1 over 1, that's 4 over 2, that's going to be 9 over 3. Okay, so those follow just a basic square root function. They go with our reference points. So the only thing that's happened here, it looks like it's a vertical flip. So my equation then becomes y equals negative. The b is just 1 because there's no vertical flip or horizontal compression or expansion going on here. And then there's my equation there, plus 4. So do the same thing for b. It's going to be a, b, in this case, the horizontal shift is -5, so I go plus 5. The vertical shift looks like it's down 3. Okay, so this one here, it looks like it could be either horizontally stretched or vertically compressed. Okay, and we can actually do it either way, but we want to look at the reference point. So this point is 1, 2, 3, 4, and 1. Normally it would be 4 over 2 up. So based on that, we know that this is we can say that this is a vertical compression of 1/2. We should check another coordinate though. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 16. Normally we go 16 and the square root of 16 is 4, so we should go 4 up, but we've only gone 2 up. So again, that confirms my vertical compression of 1/2. So I'm just going to keep this as 1/2, and then this becomes x plus 5 minus 3. Now it's important to note that that vertical compression and horizontal expansion compression can be done the same. So it could be, we can either express something as a vertical compression or a horizontal expansion. What we want to do is use these reference points to be able to find an easy compression or expansion factor. So we choose horizontal if it's easier horizontally. We choose vertical if it's easier vertically. Now this could just as well have been expressed horizontally, but it would have given me an awkward number to work with horizontally. Okay, I would have ended up with a horizontal expansion of root 2, which is a little bit more awkward to find. So for C, we end up with y equals, my vertex is going to be at, it looks like -5 again, or +5 this time, so -5, and then it looks like it's down 1, so -1. And then I'm going to look at my reference point, so I go 1 over 1, 2 up. Okay, so normally I would go 1 over 1 up, so that looks like it's a vertical expansion by 2. So I'm going to check it on my next point, so I go 1, 2, 3, 4, 1, 2, 3, 4. So normally I would go 4 over, square root 4 is 2, so it would go 2 up. So again, the 4 up confirms it's a vertical expansion. I'm not going to express it as a horizontal compression. I'm going to express it as a vertical expansion of 2. Now horizontally, it's been flipped, so I need to express my negative there, and then I have my function. And for D, again, I'm going to start with the same thing. It's a horizontal shift to the right 4, so -4. and it's gone up 5. Now this has been flipped horizontally and vertically, so I have to make note of that. But then I want to get my compression expansion factor. So here I go 1 over 1, 2, 3, 4. So it looks like a vertical expansion of 4. I'm going to confirm that with another point. I'm going to go 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8. So normally 4 goes square root of 4 is 2. I've gone down 8, so that's a 4 times expansion. So that is, I'm going to write that as negative 4. Okay, this is a vertical horizontal flip, so I'm going to do x minus 4 plus 5. Okay, so there's my equation. Now I'm going to show that we could actually do this as a horizontal. We can do this also algebraically and find out the a value algebraically. So I could do this. I can just start with y equals a square root negative x minus 4 plus 5. And then I can plug in an actual value, and I can actually calculate a based on knowing that I've got a horizontal flip involved here and my vertex. So plugging in that coordinate, y equals 1, x equals, in this case, 3. Solving for a, get negative 4 equals a times, this becomes negative of negative 1, so square root 1. And I can solve for a is equal to negative 4. And that confirms my a that I got more of from a counting method and using reference points. So this could be done algebraically as well, but if you know your reference points, it's easier to just count and figure out the ratio from there.